Okay, so this video is going to be brief. Chapter 17 homework, done by me. This is actually done from last semester. So I think that was the summer that I had it. So actually, this is problem 1. Part A and B, and then this is problem 2, part A and B. And then this is problem 3. I honestly haven't looked through this yet because it was from last semester, so I hadn't had to really do much yet. But I remember them not being that hard to do, and they actually all look really simple. I haven't really even looked over this yet, which is really not good, but that's the homework. And I just don't know the details because I haven't looked through them again yet since last semester, but this is from when I did it last semester. So that's the homework. Here you can see all the work that I did. Let's just look at this one, for example. Let's try and remember it in my head. 2 identical slender rods AB, BC are welded together, form an L-shaped assembly. Assembly is pressed against the spring at D and released with position shown, knowing that the maximum angle of rotation of the assembly's subsequent motion is 90 degrees clockwise, or counterclockwise. Yeah, that's counter. Determine the magnitude of the angular velocity of the assembly as it passes through the position where rod AB forms an angle of 30 degrees with the horizontal. So knowing that the maximum angle of rotation of the assembly in the subsequent motion is 90 degrees counterclockwise. I'm assuming they're meaning that that is the max rotation at which all the energy will be dispersed in the rotation. Not that it can't go past 90 degrees, but rather it doesn't. It reaches 90 degrees, and that's as far as it goes. So this is just for the bar, and this is for this bar. Then 1/3 mass. This is sort of looks like some sort of. Okay, yeah, this is abbreviated form of my I sub B. 30 degrees. Velocity 2 equals this, height AB and height BC, which will be different. So then you take your weight, and this will give you, well, you set it equal to your velocity. So then your T, I wonder what T is standing for here. T2. I don't know what T2 is standing for. Maybe I'll figure it out as we go. I sub B, W squared. So this is my T2 and this is my V2. This is my, where's my T3 and this is my V3. T must, what the heck is T standing for? Oh, I'm looking at the wrong thing, that's why. Okay. I'm still not remember what t is, but I can see how I set it up here. This is one side of the equation, this is the other side. And we solve for more omega, which tells me my angular velocity, 7.089 radians per second as it goes through there, which will be slowing down as it goes, so it'll continue to decelerate. It's really interesting. I really want to know what t is. What the heck is t representing? I can't remember. Anyways, I'm not sure how much credit I'll get for this because I'm not really remembering anything. T. It just must mean it's another way of saying energy. And with relation to mass. That's what I see it being. Like the conservation of momentum and energy. That's what these all look like. So these shouldn't be too hard. I like conservation of energy problems. That one's a little more complicated. I'll have to look through that. That one's not too bad. I remember doing this one, thinking it was sort of cool. And then also, that's so cool, because we got to take into account the moment of inertia of the Planck. And fortunately, these are done at each end, so we're probably doing from the end point. I don't know if that's actually what was used here, but that's what, in my mind, it should be. Where it looks like we're taking into account that part. Velocity E equals square root 2gh, which is a formula that I see all the time, and I don't understand how that actually gets there. But I mean, I don't understand. Well, I don't want to have to do the algebra, but obviously I can trust that that's how the algebra works out. I just really don't understand why it's square root 2 times that. But if I just did the algebra from the beginning, I'd understand that. Then you find these formulas and you work it out. I don't see an H formula there. Oh, there it is. There's my H formula. V1, that must be my initial, yeah. Or well, my velocity upon impact. And velocity of her will be this. And that's the height she'll go. Okay. That's chapter 15, or what chapter is this? 17.